Okay, we're going to look at some simple trig equations, starting with 4 tan x minus 3 is equal to 0, and we're looking for solutions that lie between 0 and 360 degrees. So it's a National 5 type question to get started. So it's 4 tan x equal to 3 and tan x is equal to 3 over 4. Get the cast diagram up. Okay, so I'll be in all in tan x equals tan inverse 3 over 4. Punch that into the calculator. Okay, and that'll give me 36.9 degrees. In the tan quadrant then, it's 180 plus the angle, and that is 216.9 degrees. Okay, example 2. Let's go for, I'm going to solve 2 sine p plus 1 is equal to 0. And we're looking for solutions for p between 0 and 360. So that will be 2 sine p is equal to minus 1, and sine p equals minus 1 over 2. Okay, so our routine there is to change that from negative to positive, but instead of looking in all in sine, we now look in tan and cos. Okay, so p equals sine inverse 1/2, so my exact value there is 30 degrees. However, I'm not in the O quadrant, I'm in the tan quadrant, which will be 180 plus the 30, 210, and in the cosine quadrant, which will be 360, take away the 30, which is 330 degrees. Okay, let's move on to some more kind of higher content now, and some compound angle questions. So this time we've got a double angle. 5 tan 2x is equal to 3. We're looking for solutions that lie between 0 and 360. Okay, so my first move is to double the limits. So the lower limit, 0 times 2 is 0, and the upper limit, 360 times 2 is 720. Okay, so tan 2x is equal to 3 over 5. 2x equals tan inverse 3 over 5. So at this point I'm getting my cast diagram down, and I'm in the L quadrant and the tan quadrant. Okay, so enter into the calculator shift tan 3/5, and that is 31.0 degrees. I'm also in the tan quadrant, which is going to give me 211.0 degrees. Okay, so I'm looking for solutions up to 720. So remember that the tan curve repeats after 180 degrees. So 31 plus 180 will give me that 211, but 211 plus 180 will give me 391.0 degrees. And then 180 onto that will give me 571.0 degrees. And then a further 180 will give me 751.0 degrees. As I can see, that's out with the limits, so I'm going to get rid of that one. I then divide all my answers by 2. And that will give me 15.5, 105.5, 195.5, and 285.5 degrees. Okay, next question. We're going to solve 2 sine t plus 60 minus 1 is equal to 0, and we're looking for solutions that lie between 0 and 360 for t. Okay, so the compound angle this time is telling me to add 60 degrees, so the lower limit becomes 60 and the upper limit will be 420. So 2 sine t plus 60 is equal to 1. Sine t plus 60 is equal to 1 over 2. T plus 60 equals sine inverse 1 over 2. Okay, so get the cast diagram up, and I'm in the L quadrant and the sine quadrant. So t plus 60 is equal to, we'll shift sine 1/2 is 30 degrees, and in the sine quadrant that will be 180 take away 30, which is 150 degrees. Now I can see at this point that 30 is below my limits for our solutions for t plus 60. However, if I add on 360 onto that, that takes me up to 390, which is an acceptable solution because I can go up to 420. Remember that the sine function repeats after 360 degrees. Okay, so then 150 take away 60 is 90 degrees, and 390 take away 60 is 330 degrees. Okay, let's try another. And 8 plus 3 cos 4x is equal to 9. And I'm looking for solutions between 0 and 90. Okay, first of all, it's a quadruple angle, so let's multiply the limits up. 0 times 4 is 0, and 90 times 4 is 360. And 3 cos 4x will be equal to 9 take away 8, which is equal to 1. Cos 4x is equal to 1 over 3. 4x equals cos inverse 1/3. And I'm going to get my cast diagram up. Okay, so I'm going to be in on cos. So 4x equals shift cos 1/3, throw that into the calculator. That's 70.5 degrees, and in the cosine quadrant that's 360 take away 70.5, which is 289.5. Okay, if I then add on 360 to either of those, that will take it may be on 360. So I'm now going to divide both of these by 4. So 70.5 divided by 4 is going to give me 17.6 degrees, and 289.5 divided by 4 will give me 72.4 degrees. Okay, next one. 2 sine 3x minus 70 plus root 3 is equal to 0. I'm looking for solutions that lie between 0 and 180. So I need to treble my limits and take away 70. So treble 0 is 0, take away 70 is minus 70. And then treble 180 is 540, take away 70 is going to be 460. Okay, so 2 sine 3x minus 70 is equal to minus root 3. And then sine 3x minus 70 is equal to minus root 3 over 2. Okay, so I'm going to change that to a positive result. Sine 3x minus 70 equals positive root 3 over 2. Okay, I can then get my cast diagram up, and I'm not going to be in all in sine because I've changed from negative to positive. I'm going to be in tan cos. So 3x minus 70 is equal to sine inverse root 3 over 2. That's an exact value, which is 60 degrees. However, I'm not in the all quadrant, but I'm in the tan quadrant, which is 180 plus the angle, 240, and in the cosine quadrant, which is 360 take away the angle, which is 300. Okay, so if I was to add 360 onto either of these, that would take me with 460. However, if I take away 360 from 300, I'll have minus 60, which is within range, so I'll include that as well. Okay, so it's then 3x equals minus 60 plus 70, which is 10, 240 plus 70, which is 310, and 300 plus 70, which is 370. That's then 10.3, 103.3, and 123.3 degrees. Okay, let's try one more. Cos 2x minus 45 is equal to 1. I'm looking for solutions that lie between 0 and 360. 2x minus 45 equals cos inverse 1. Cast diagram. I'm in on cos. 2x minus 45 is equal to, we'll shift cos 1. Okay, so that's 0 degrees, and in the cosine quadrant, 360 take away 0, 360. Let's remember to expand up our limits. So the limits are going to be doubled, and then I take away 45. So 0 times 2 is 0, take away 45 is minus 45. 360 times 2 is 720, take away 45 is 675. Okay, so I've got 0 and 360. Cosine repeats after 360 degrees. So that's going to be 720. Okay, that's out with my limits. So add 45 onto both solutions, 45 and 405, and then x equals 22.5 and 202.5 degrees.